start our first real content video of this semester. 8.1 Factors in Problem Solving. So in this part, we look at the algorithms from the high level understanding. All right, first, let's look at this question. Why we need to study algorithms? Okay, this question first. The goal, solving computing problems. Here, what's the meaning of computing problems? Here we like to make it broader, as general as possible. Computing problems. The problems you need to do computation using computers. That kind of problems. Okay. In order to do that, what do you need? What preparation do you need? Learn knowledge and skills. So, for example, in this class, you need to learn the knowledge and the skills. After that, then to solve the problem, to be smart, because in order to solve a computing problem, usually you have many different ways. Some ways very smart, but there are many bad ways. So in this class, we have chance we can compare. If we use different ways to solve the same computing problem, so you can see the result is huge. The difference is huge. So later we will see that example. Many examples like that. Next, here a typical situation for a computer professional. So I can see most of you will be computer professionals, right? So then your role as a computer professional, problem solver. You need to solve many, many computing problems. All right. So the typical situation, you are given a computing problem to solve. You need to use your, creativity, your knowledge, your skills, your creativity to solve it. And most of the time, the problem is not very easy. So you really need to find some very special way to solve. That's the typical situation. Okay. So now we want to think in this way, factors that may help you solve the problem. What are those important factors? So we look at algorithms in this way, factors. Let's use our experience to understand the factors here. First, I want to use chess game. So the chess game, when two players playing chess game, can we treat it as a computing problem? If we want to use AI to solve it, AI software can do much better than a human player. Even human world champion, the AI, program can beat a human world champion easily. So we can treat it as a computing problem, chess game. Okay, so that's one example. Another, football game. We may not be able to treat it as a computing problem, right? If in the, game, computer game. But here, the real world football game. So let's look at the real world football game. Even if it is not a computing problem, but they share a lot of common elements. So here, think about what factors are important in chess games and football game? Yeah, here. One, I put here, strategies. Strategies. Do you think it's important to have a lot of smart strategies in chess game? Do you think, football coach, they will have a lot of, very rich, collection of strategies, smart strategies? Yeah, definitely. It is important factor. Strategies. Okay, all right. Then let's look at other than strategies. Any other factor also important? Okay, all right. Here, I want to use a typical situation we may have experienced before. I saw this kind of situations many times before. Near the end of football game. Okay, all right. So two teams in a very close game. The difference, 1 point difference, like that. Then the last a few seconds, then one team has a chance to play a field goal here. Then you can see a lot of pressure on that kicker player. Yeah. If he miss it. Okay, because you only have one chance. Okay, if you miss it, you lose the whole game. If you make it, then you win the game. Yeah. So look at that. What's the factor about that? Because the strategy part already, during the whole game, both sides already applied all the successful strategies to get to the point, last minute, that situation. Okay? So then, to make it or miss it, make it or miss it, it is very hard to predict. Okay? What's that factor? Execution. The player, how the kicker can execute that critical task. Okay? Yeah. So, our second important factor. Strategies, first one, execution, second one. Here in our computing problems, these two factors also important. Strategies, even if you have strategies, you need to be able to implement your strategies effectively. So execution. That's the execution factor. Okay? All right. So let me summarize these two factors, okay, to get to our algorithm. So what is an algorithm? Okay. Step-by-step procedure, because after you get a complete algorithm, you need to have step-by-step procedure. And this procedure contains strategies, because you may need to use multiple strategies. So not one or two. Sometimes you need several strategies. And you need to put the execution details in your procedures. That whole package. So we treat it as an algorithm. How about that? How about this understanding? So this is our first view of algorithms. All right, so that's the 8.1 video.